Thank you, sir. Thank you, Professor Manas and Dr. Tejas for chairing this session. First of all, I would like to thank all the audiences who will be listening to me for next 10 to 15 minutes. I am Dr. Sanchayita, and I have been working in Haflong Government College in the Department of Chemistry. And my paper ID is 95. And the topic that I am going to deliver today is the beneficiation of iron ore by selective flocculation using surface active agent, settling study, and characterization of beneficiation waste for value addition. Now, we all know that India has, some iron ore reserves, mainly in the states of Jharkhand, Orissa, Goa, Karnataka, and Chhattisgarh. However, these iron ores are not 100% extracted from the reserves, and the soft nature of these iron ores is one of the main issues, which are also mixed with high amount of clay minerals. Now, these are, I'm going to study the iron ore fines and slime. The difference between fines and slime is the sizes, where slimes are smaller than the fines. And we are going to have environmental protection angle with this study, as this conference demands. So how this study will, influence the environment, or it will be a sustainable one. Now, if we go for high alumina content ores, then it will obviously require more coke as well as more amount of limestone during the smelting process. If you reduce the alumina content, or if you have certain processes which can reduce the alumina content as well as the silica content, then that will be beneficial for our, to minimize the amount of renewable sources like coke and limestones. That is one way of environmental protection. And another way is, most of these slimes and fines, they are thrown into the environment. So better to collect as much as ores from these waste rather than throwing them directly to the environment. Is my slide changing?
Yes, it's changing.
Okay. Okay. So the way we wash our clothes to clean our clothes, similarly we can wash the iron ores with the use of surfactants. Now, how we wash, it's not like simple washing like clothes and our, daily utensils. It's a bit different. So we have to add some surfactant with the iron ore suspension, so that the dirt, or the, this unwanted alumina and silica, they can come out with the suspension, and they can be removed easily. And from this suspension we can again extract some amount of iron ores, which is again be beneficial in terms of, industry as well as in terms of environmental protection. Now, if we take 10% of slurry, for example, and if we maintain the pH of the slurry at 8, and I will be talking about why pH 8, and if we add different surfactant, sodium humate and AD200, as well as starch as a flocculant, and if we take the dispersed phase, then it will recover 4 to 6% of the iron ore. And these ores, these dispersed phase, have been studied using different methods, international standard methods, which I'll be discussing in the later slides. Now, this is what different sections of iron slurry, you can say. The lower portion is, the upper portion is the dispersed gangue, and the lower portion is flocculated hematite. And this gangue suspension also is studied using different surfactants, surface active agent. And while this surface active agent is also an anionic, and this dispersed phase is also negatively charged because of the pH 8, so there will be repulsion and dispersion will occur. However, in the flocculated section, the interaction between the surface active agent and this portion will be attractive because of their opposite charges, and the flocculation will occur. Now, as I told, what is so specific about pH 8? Now, if we consider the pH 8, then the better quality of concentrate, that is iron, more than 60%, can be obtained at pH 8. And moreover, isoelectric point of hematite is around 8.5, pH 8.5. Now, that is one reason. And from this study, if we study for different pHs, and if we study the amount of alumina silica ratio and alumina iron ratio, then this is the lowest ratio we can get at this particular pH. And to get better or more iron from iron ores, the ratio has to be around mm, 0.05 for alumina iron ratio, and for alumina silica it has to be less than 1. Now, these are several experiments that we have done with the suspension. First, we have done the stability of suspension of the slime at that particular pH, and we have studied the amount of surfactant agent, uh, and we have found that these amounts are very effective in producing the stable dispersed phase rather than without the surfactant. Now, these points have been theoretically plotted or theoretically plotted by using the first order kinetic equation, and it was well fitted with the theoretical equation. Now, similar experiment has also been done with the fines, the suspension of the fines at that particular pH, and it has been studied. Hasn't found that humate as a surfactant, it produces more stable dispersed phase than that of AD200. Now, another experiment, similar experiment, it shows that the humate alone, and humate along with starch with the 5 and 10 weight percent, as you can see from these points, at that particular pH can produce around 1.5 times more stable suspension in case of iron fines than in case of iron slime. So these are different studies which can, these are the setting of parameters through which we can extract more and more irons from the waste materials. Now, if we study the stability of suspension at 10% slurry, okay, then in case of slime, both humate as well as humate and starch combination can produce equally almost comparable stable suspension. But if we go for surfactant active agent, then this surfactant active agent can do much better than humate and starch. Now, this particular slide says about the efficacy of our surfactant active agent, and it signifies that the hematite concentration from the slurry, from the slime slurry, is reduced in case of AD200, and which is a better option than humate. Now we have increased the percentage of slurry. Previously we have done with 10%, then we have done with 20%, which I have not shown, but 30% I have shown. Just I have included just to give you an idea how these surfactant active agents can remove or can recover a significant amount of the concentrate, that is iron, from the slimes. Especially about 60% slimes iron can be recovered using simple AD200 surfactant active agent. And then we characterized the dispersed phase using XRD techniques, and these are different peaks which tells us about the mixture. That's for example, D value at 7.144, it signifies that there is a mixture of chloride and kaolinite. Similarly, different D values give us different characterizations, and these are the these are the contents that was present in the dispersed phase. Now, if we go for FTIR study, that also gives us certain amount of information regarding the dispersed phase, and these are well coordinated with the previous data.
Ma'am, please do it fast, another 1 or 2 minutes.
Yeah, I have only 1 or 2 slides maybe. So these are SAM EDX analysis which are complement one another, and these two this particle A, for particle A this is the SAM and this is the EDX analysis, and this from here we can say that it has certain amount of silicon and oxygen, and particle wise, for example B and D, and C indicates there is a presence of iron containing geotite mineral phase. So what are the outcomes of from this study? Although I have tried hard to sum up in 15 slides, so it gives us an effectiveness of the surfactant agent, which surfactant agent will be more effective in extracting those irons from those waste materials, and what is the influence of the dispersant, and how the settling rate is dependent on the dose of dispersant from that first order kinetic study. And then we could know what is the content of the dispersed phase from those various analyses. Then lastly, of course, experiment versus theory, and this experiment is well coordinated or well supported by the theory. So this is my college. This a few glimpses of half long, and thank you for listening to me. I hope I have finished it on time.
Materials for environment protection and remediation. I am from Tumkur University. So next slide. I'm speaking on a novel one-pot synthesis strategy for beta manganese vanadate nanorods for sustainable and on-demand advanced supercapacitor electrodes and as negative electrode materials for lithium-ion batteries. So metal vanadates nanomaterials can be used for energy storage devices due to their high specific area and excellent electrochemical properties. So this is the schematic synthesis of our material. So we have taken manganese vanadate and ammonium metavanadate in the ratio 1:1. Without adding this ionic liquid, we have taken 50 ml of water into a Teflon liner. First, we stirred, magnetically stirred for about 20 minutes, and then taken in an autoclave in a Teflon liner and exposed to a hydrothermal treatment. Nearly heated for 170 degrees for 20 hours. So then the product was centrifuged, washed, dried at 80 degrees centigrade for 4 hours. We got a brown PPT of beta manganese vanadates. So the same experiment was repeated using this ionic liquid DOMIMS, that is 1,36-dioxoheptane 3-methyl imidazole methane sulfonate. This is the ionic liquid prepared by going through the literature. Okay. The same experiment is repeated with ammonium manganese acetate, ammonium vanadate, the 1:1 ratio. 10 ml of this ionic liquid is taken, 40 ml of water, magnetically stirred for 20 minutes, and hydrothermally treated 170 degree for 20 hours. Again, centrifuged, dried, and washed. We got a brown PPT of ionic liquid beta manganese vanadate. So different characterization techniques were carried out for this synthesized product, both bare manganese vanadate and ionic liquid beta manganese vanadates. And this crystalline size was calculated. We can see the crystalline size treated with ionic liquid, it is reduced to about 30 nanometers. And we have calculated lattice parameters also. And IR spectroscopic studies also we have carried out. We can see at the peak at 715 centimeter inverse, it shows manganese oxygen MNO stretching vibrations. 799, 730, this is fingerprint region. We got VO stretching vibrations. At 533 and 681, 87 centimeter inverse MN stretching vibrations. 1120 centimeter inverse V double bond O CN stretching vibrations. Okay, and 3415 centimeter we got OS stretching vibrations. So we have also carried out the SEM studies, EDAX studies, XPS studies to confirm the oxidation state of this manganese and vanadium, bed studies to determine the pore diameter, surface area, and also the pore volume. So the bed studies here it is not shown. The bed study shows that the pore diameter of the compound is 3.4 nanometer, pore volume is 0.041 cc per gram. And XPS study shows that the manganese shows +2 oxidation state coexisting with +3 and +4 oxidation states. Whereas the vanadium, it shows +4 and +5 oxidation states. And we have carried out UV visible DR spectroscopic studies to calculate the band gap. You can see this is beta manganese vanadate. This is ionic, red color is ionic liquid manganese. So when it is treated with the bare component, is treated with ionic liquid, we can see the band gap is decreased. So the decrease in band gap is essential for the study of these battery studies. We have carried out lithium-ion battery studies and also the supercapacitor studies. So the SEM study shows that this is the ABC. They are the images of beta MNV, and this is the images of ionic liquid beta MNV. You can see the difference here. You have got almost agglomeration like products, but here when ionic liquid is covered with that, we got rod-like structures were observed that shows that this here the ionic liquid acts as a surfactants to improve the catalytic shape of the compound we have synthesized. And TEM studies, TEM also we have carried out. The TEM studies, it is in correlation with the SEM studies. The EDAC study shows that it mainly contains oxygen, vanadium, and manganese here. See, we have carried out the photoluminescence studies. We know that the photoluminescence is mainly caused by photogenerated electron-hole pairs combining. To understand the efficiency of charge separation, excitation wavelength, you can see at 391 nanometers. They show emission at 488 nanometers and 541 nanometers. So this is beta manganese vanadate and IL, ionic liquid manganese vanadate. This first one that shows higher peak PL intensity. Then the ionic liquid beta manganese vanadate, because here in this case, in the first case, there is a greater charge carrier separation, recombination is there. So the separation in the INC may enhance the photocatalytic activity. So in the beta MNV, in that case, there is a more combination. Whereas in the case of ionic liquid beta MNV, there is a charge separation is there. So it enhances the catalytic properties. So coming to the electrochemical impedance studies we have carried out. So CVs are used for this. This is beta MNV, ionic liquid beta MNV. You can see a duct-shaped CV is seen here. So this shows that here the conductance is more in the case of beta ionic liquid beta manganese vanadates. So CV studies were used to study about the supercapacitor studies. This is the oxidation peak, anodic, and this is the cathodic reduction peak. So you can see the 6 different cycles were carried out here. The current versus here you can see the current versus E, energy density, the cyclic voltammeter studies at 25 millivolts per second, at 50 millivolts per second, at 100 millivolts per second we have carried out. At 8 different cycles also you can see the peak remains as such. The shape it does not change here. At about 0.62 volts and 0.91 volts. Okay. And this is as the 100 cycles, number of cycles increases, you can observe that the shape gradually changes. So the scan rate, we have calculated the specific capacitors versus scan rate and specific capacity versus current density. You can see it is maximum at 2000 milliamperes per gram. And there you can see a linear plot in the case of specific capacitors versus energy density. So another thing we have carried out, the most important is lithium-ion battery studies. So you can see here, that this is a delithiation peak and this is the lithiation peak. So this is the first cycle. You can see there are a small peak is there at about 1.66 volt and another one at about 0.53 volt. So this 1.66 volt peak, it disappears at the second cycle, okay, in the cathodic, or you can say lithiation, because this suggests that the disappearance of this, according to equation 1, this suggests that there is a irreversible reaction was involved in the initial lithium process. Okay, and 2 peaks we can see here. This is 2.61 volts and 0.81 volts, 0.176 volts. In between these two, a broad peak is obtained at 0.81 volts. This is mainly due to delithiation process as per the equation 4 and 5 you can see. So this is 2 at the 2 equation 2, 0.53 volts where the manganese metal is obtained. So 0.53 volts is attributed to the solid electrolyte interface formation along with the entire lithium ions being taken up. So these equations 1, 2, 3, 5 shows how the lithiation and delithiation process takes place in this. Next one is lithium ion battery studies. So you can see the charging capacity and discharging capacity here. So as you can see from the graph, you can see here the capacity, the cycles, number of cycles and Coulombic efficiency. The Coulombic efficiency it remains constant up to 100 cycles. 99%, nearly 99% of Coulombic efficiency it maintains both in the discharge and charge capacity in this case. So this work has been published in the Journal of Energy Storage, which carries the impact factor of 9.4. And we thank SRM University Chennai for carrying out the battery studies. And I also thank our research collaborator Dr. Nagaraj from SIT, Siddhaganga Institute of Technology, Tumkur. And this is our research group who contributed for this work. So with the conclusion of this work, we can say this beta manganese vanadate used for energy storage devices such as supercapacitor and batteries for the first time. So ionic liquid is effective in changing the material properties and has played an important role to change the morphological, optical, electrical, and also the catalytic properties. So maximum capacitance of this, you can observe this 191 faradays per gram at 25 millivolts per second. So this beta manganese vanadate, it is used as a anodic rods, anodic nanorods material to deliver excellent capacity of 441 milliampere hours per gram at 0.2 Coulombic rate and reversible stable capacity of 253 milliampere hours per gram at 1 Coulombic per rate. So a discharge capacity of 168.5 milliampere hours per gram was achieved after 100 cycles. You can see 100 cycles of charge discharge with only 20.5% capacity loss. So you can see here the charging and discharging, the black and blue color, it almost the Coulombic efficiency remains 99% even at 100 cycles. So thank you for the organizers for giving me an opportunity to present our student. This is actually our students' work. This is. So they mainly worked with the collaboration with the SIT and the lithium ion studies were carried out at the SRM University, Chennai. So thank you organizers once again for giving me an opportunity to show this work.
Sir, my topic is a comprehensive review on properties and application of cationic polymers.
Ma'am, can you come to your first slide?
Yeah, I'm trying to come, but I think there's some internet problem sitting in the university area and there's some internet basis, so I think I'm not able to do it. Sir, I'm trying to do it, but my topic is a comprehensive review on properties and application of cationic polymers. So this is my first slide, that is introduction part. That is it visible now, sir? First slide?
Yeah.
Yes,
Now
yes,
it is visible.
Actually, I'm working with my students, sir, on the preparation and synthesis of the novel polymers and their application in the industrial water. I'm working in the collaboration and one is DST project I'm having for the startup project of 5 lakhs only, a small project for the treatment of the sugar industry wastewater with the use of the polymers, but not only polymers along with the coagulant. So we all know that water is a basic human need. We all know that a large population of India is staying in the rural area and people are not having access to the clean drinking water and they are compelled to use the turbid and the other contaminated water to drink and to go through the different diseases. So in that case, here there's a growing demand for the water resources which create urgent need to link research with water management. I won't go for so much details here because it is known to all. Actually, I'm working on the characteristics of pollutant and how these pollutants can be removed. It is a very interesting fact which has been studied by in the literature that there are different kinds of the polymer impurities, that is suspended impurities and the dissolved impurities. We are normally known to this that those impurities which are being seen with the eyes are suspended and those we cannot be by dissolved. But this is not the case only. If you go in the detail, then you will study that the whole impurities has been divided into different categories. They are the settlable suspended, non-settlable suspended, and dissolved impurities. I am mostly working on the settlable and the non-settlable suspended impurities. for the industrial wastewater. Specifically, I'm working on the sugar industry wastewater, where I've done the collaboration with the Dhampur Sugar Industry Mill, that is located in the UP. If you will see it, you will find.
Ma'am, can you come to the video mode, ma'am?
It is there, sir. My video is open, isn't it?
You're not able.
I don't know. I have opened it and it's on from my side, sir. I'm sorry. I don't want to get into more it because I'm thinking
Fine,
that it
fine.
may, technical
No
error
issues.
can occur. So if you go for the interesting one, then you will observe that normally people think that the BOD, COD, and these compounds are mostly present into the soluble condition. But you will observe in this table that most of the BOD, biological oxygen demand, chemical oxygen demand, TOC, and for these all are mostly present into the suspension. However, turbidity is present also into the suspension. So you can see that these all parameters are mostly present. High percentage of them are present into the suspended types, and very few little compounds are present into the dissolved types. So they on the removal of these polymers have been used very successfully and given a very, very good result. If we go in the detail, then we say that these suspended matters, we know that they are organic and inorganic in nature, and they carry significantly high pollutant level as compared to the soluble water pollutant. Mostly we can see that these suspended solids are mostly anionic in nature. They are having negatively charged. So they can combine with the both, that is cationic polymers as well as anionic polymers. We know that polymers are of three types, cationic, anionic, and neutral. But mostly the charged polymers work very efficiently into the water treatment. So if it works with the cationic polymers, it undergoes the charge neutralization, and if it goes from the anionic polymers, then it undergoes the polymer bridging, because both are then anionic in nature. This method is coagulation flocculation method is being used for the removal of these pollutants from the sugar industry wastewater with the help of polymers. Although I've also worked on the surface water, lot of work I've done the surface water, I've worked on the groundwater, I've done work on the Yamuna river water also by the method of coagulation and flocculation. So we can say that coagulation flocculation is the one of the most preferred method, economical method, mostly used for the removal of colloidal suspension, aggregating them, binding them together for the ease of sedimentation. Come to the next one. But one more interesting fact just I want to discuss, or you can say I can share with you, that I have worked on the polymer as a primary coagulant and I have worked on the polymer as a secondary coagulant. They are talking about that when we take as a primary coagulant, then dosage are higher. But when we take it as a secondary coagulant, you will be surprised to know that it works even at a 5 milligram per liter, 7.5 milligram per liter, and 10 milligram per liter. It can remove the these contaminants from the water in more than 90%. That is the best part of these polymers. And the method is also very, very economical. So say there, I have used these organic polymers in combination, or you can say in conjunction with any inorganic coagulant, existing organic coagulant. Like you can take lime or you can take alum. When you take only lime and alum, then obviously large quantity of sludge is present. But when you combine it with the organic polymers, then what happened? The quantity of polymer decreases so low that it comes down the toxicity level. There's a rule in the US and Japan and many countries that you cannot use more than 50 milligram per liter polymers in any water, because it will introduce the toxicity into the water. So whatever I have worked, I have taken the polymers as a secondary coagulant, not as a primary coagulant, or you can say as a flocculant. Because inorganic coagulant, as I told you, is not sufficient enough to get the best result. And it is being used also from the decades. There's nothing new into these inorganic coagulant. But I'm taking it in conjunction with this. Here I'm using polymers which are inexpensive. I'm preparing those polymers which can be prepared in a shorter time, which can be economical in nature, and that can be prepared easily in the lab. As I said, that I'm not using it as a primary coagulant because I have seen it that they introduce toxicity in the water. And whenever you will use it as a primary coagulant, it will you have to add at least more than 50 milligram per liter polymer, which is not at all permissible as per the norms. Now come to the properties of polymers. So in the presence of suspended solid, what happened? That there are three kinds of polymers. It is known to all: the low, medium, and high. And there are charge density also, which is also very, very important, whether you are having the low charge density and high charge density polymers. But after the conclusion, I have found it that more than molecular weight, the charge density is a more important factor for the removal of the suspension from the water. When we take high charge density polymers, it gives a better result as compared to the low charge density polymers, because polymer bridging and charge neutralization is being done more successfully as compared to that. This mechanism has been shown into this figure, that how the cationic flocculant neutralize the negative charge of colloidals, like those suspended particles moving into the water, they are negatively charged. When they combine with the polymers, that is cationic polymers, they undergo the charge neutralization and they converts it, and by the coagulation flocculation method, they are being removed. 30 minutes you need to go on that for the jar apparatus method for the rotation per minute. That rotation per minute, in the first minute you have to take 100 rotation per minute, then you have to decrease to the 70 and further decrease to the 50, and after half an hour keep it for the sedimentation, and then you find the result. You will get the result is very, very tremendously good, and they undergoes by the kinetic aspects of flocculation, that they undergo first mixing, then they get adsorbed on the surface, and the flocculation is being done. I've made a short and crisp slides. Anything you want to ask, I will be ready to share. I've just filed a patent also on a new novel polymer which we have synthesized, that is a polyamine based polymers. Just last month only we synthesized one polyamine based polymers, and we could get a result of 95% removal of suspension, like COD, BOD, turbidity and all that. Although I have not studied till date about the heavy metals, which I want to do in future, for the removal of these contaminants from the water, and we got a very, very successful result. And the polymer which we have prepared have been prepared. These polymers have been prepared only within 5 to 10 minutes and are very, very economical. If you will ask me, then I can tell you that only 2 rupees per liter of wastewater, only 2 rupees is being spent on the removal of per liter of water from the very, very polluted sugar industry wastewater. That result we have shared with the industry, and we are talking to them. Anything you want to ask, I'd be happy to answer it.
Thank you, madam, for your presentation. And yes, any questions from the audience?
I have published 2 papers last year on this, sir. One in the 8.25, one in the 4.5 impact factor general for this work. This year we have filed a patent. If we get successful, let's hope for the best. Thank you, sir. Thank you for giving me an opportunity.
Yeah,
Good evening to
Gopinath,
all of you. My name is Arshdeep Kaur. I am pursuing my PhD under the supervision of Dr. Piperazine and Dr. Sanjeev Kumar sir at Shri Guru Granth Sahib World University, Fatehgarh Sahib. I am going to present here on the topic innovative hydrothermal synthesis of clove extract mediated cobalt oxide nanoparticles for enhanced photocatalytic dye degradation and environmental remediation. First of all, introduction to nanotechnology. Nanotechnology is the study and development of materials on the...
Can you make it full screen? It is not full screen.
Is it now full screen, sir?
Yes.
Okay.
Proceed.
Nanotechnology is the study and development of materials on the scale of atoms and molecules, and it is from the range from 1 to 100 nanometers, and 1 nanometer is a 1 billionth meter, that is 10 raised to power minus 9 meters. My work is on cobalt oxide nanoparticles. So first is introduction to cobalt oxide. It is a magnetic metallic element which is used mainly in batteries, pigments and paints, lithium-ion batteries, dyes, energy storage, and catalysis. Pure cobalt is not stable at room temperature, so it is exists in 5 other modes, that is cobalt monoxide, dicobalt trioxide, tricobalt tetroxide, cobalt oxyhydroxide, and cobalt dioxide. Among them, CO3O4, that is tricobalt tetroxide, is a thermodynamically stable at room temperature. It is a spinel structured antiferromagnetic p-type semiconductor material. We have done the photocatalytic activity. It is an advanced oxidation process that is used for photodegradation of toxic compounds of dyes. For the photocatalytic degradation of textile dyes, researchers have employed various types of nanomaterials like titanium oxide, zinc sulfide, cobalt oxide, and CDS, etc. Among these, we have two CO3O4 nanoparticles that has generated great interest in the area of dye removal from the polluted water. For the synthesis of nanoparticles, there are 2 methods, that is top-down method and bottom-up approach. We have used green synthesis method. In green synthesis, Plant synthesize nanoparticles and combine the nanotechnology with biotechnology. Synthesis from biological derived extracts. Several advantages shows, that is rapid synthesis, easy to handle, non-toxic, and most importantly, lack of costly downstream processing required to produce the particles. In this paper, we have synthesized CO3O4 nanoparticles using the clove extract. First, for the preparation of ethanolic extract of clove extract, we have dried the clove buds. Then we have pulverized the clove buds into the powder form. Then soak this powder in for 24 hours in the ethanol. Then after 24 hours, filter this. We have filtered with the Wortmann paper. Now the extract was used for the synthesis of CO3O4 nanoparticles. For the synthesis, first, the mixture of the extract and the cobalt nitrate salt was used. These both are mixed and stirred for an hour. Then for the pH setting, we have used the NOH solution. After adding NOH solution and setting the pH at 9, we have stirred for an hour. The mixture then kept in an autoclave for 24 hours at 120 degrees Celsius. After cool down the autoclave, we have washed and filtered the obtained precipitates. The obtained precipitates then dried and calcined in muffle furnace at 400 degrees Celsius for 2 hours. Then we have obtained the black color precipitates. For the analysis, we have done some analysis. First is FTR analysis. This the figure shows the FTR spectra of clove extract, and the 4B figure shows the clove extract mediated CO3O4 nanoparticles. In the figure 4B, we have seen the peak at the fingerprint region, that is at 661 centimeter inverse, was associated with the metal oxide, that is cobalt and oxygen bond in the fingerprint stretching vibration of CO3O4. This peak is indicative of CO3 positive to and oxygen bond of breaching vibration at the octahedral location. The typical peak of aromatic rings and in-plane bendings of cobalt and oxygen were both present at 1695 centimeters. These peaks demonstrate the formation of CO3O4 nanoparticles. In the region of 3400 to 3900 centimeters, the OH stretching of intermolecular bonds were attributed. This is the XRD spectra of the obtained particles. As we can see in figure 5A and 5B, 5A are peaks in 5A are identical with the JCPDS card number, which shows that the no diffraction peaks related to other impurities were observed, indicate the complete decomposition of the precursor into the pure CO3O4 phase. The average particle size was estimated from the X-ray line broadening of the diffraction peak using Sherrod relation. This is the UV visible analysis of the obtained synthesized particle. In the UV visible spectrum, we have seen the two absorption peaks were detected at that is one for is 271 and other one is at 527 nanometers. These peaks confirm the formation of CO3O4 spinal nanoparticles, which they attribute that the first peak shows the O2 negative to CO2 positive, and the second one shows the O2 negative CO3 positive charge transfer process. And this shows the two band gap energies at 5.2 and 3.34 electron volts. The two obtained band gap energies demonstrate the degeneracy of the valence band. This is the SEM analysis of the prepared particles. The SEM analysis shows the nearly sphere-like structure of CO3O4 nanoparticles with good size and shape consistency. In the ADS X-ray spectroscopy, it shows that cobalt has a 63.72% and oxygen has 36.28% weightage of the particles, which means no other chemical appears. As a result, CO3-4 sample has successfully synthesized using clove extract without introducing any contaminants. For the photocatalytic activity, we have used the methyl blue dye. For the degradation of methyl blue dye, we have used the catalyst amount of 12 mg. As we can see from the figure that that the diminishing peak at 599 nanometers, the complete disappearance of the peak after 100 minutes under UV irradiation with 12 mg of nanoparticles. Here the table 1 shows the other dyes using other methods which has been used by other researchers, that shows less than 80% of degradation, but in our case we have degraded above 90% of the degradation of dye. So the conclusion, due to the fact that the plants are rich source of naturally synthesized compounds that are easily available, eco-friendly, and in cooperation with such plants producing during synthesis avoids the uses of harmful and toxic reducing and stabilizing agents. As a result, CO3O4 nanoparticles were effectively biosynthesized in this study by reducing the cobalt salt with the help of active phytochemicals found in the clove extract, and the absorption bands were in the wavelength range of 250 to 300 nanometer and 500 to 550 nanometers, where two band gaps values were detected and respectively confirmed the production of CO3O4 nanoparticles. Sharp bands in the FTS spectra for clove extract-mediated CO3O4 nanoparticle indicates the presence of cobalt and oxygen bond. The presence of highly crystalline and face-centered cubic structure CO3O4 nanoparticles is confirmed by the XRD pattern. The FESM analysis shows the nearly spherical-like structure with the elements peaks of 63% of cobalt and 36.28% of oxygen, which were observed in the EDS spectrum. These are the references. Thank you.
Thank you, ma'am. So I'll start with the presentation, ma'am. Is it okay?
Yeah.
Yeah, ma'am. Is it visible, ma'am?
Yes, it is visible.
Okay. So good evening, madam. Good evening, sir. And I'm Ashwini Jaggal, research scholar, pursuing my PhD under the guidance of Dr. K.S. Katagi, Associate Professor, Department of Chemistry, Karnataka Science College, Dharwad. So the oral presentation which I will be doing on is a click chemistry based strategy for synthesizing Coumarin Piperazine analogues, assessment of anti-tubercular, anti-cancer, anti-inflammatory, and antioxidant potentials. So my paper ID is 080. So coming to the introductory part, so I have chosen three important moieties for my work. So first moiety is Coumarin. Coumarin moieties, as we know, they are very much having diverse pharmacological activities in various arenas. Then second molecule which I've chosen is Piperazine, which is a nitrogen heterocyclic molecule, which again has wide applications in various pharmacological activities. And I have chosen 1, 2, 3 triazoles has my molecule of study, and conjugating Coumarin and Piperazine moieties along with triazoles. I have made an effort to come up with new Coumarin and Piperazine analogues, and these are certain compounds, important compounds, which are showing good potent biological activities. And by using click chemistry approach, which has been received the Nobel Prize in the year 2022, we have aimed to create hybrid molecules with enhanced therapeutic profiles, simplifying synthesis and providing a promising strategy for developing multi-target drugs. So these are some of the molecules which is taken up from literature survey. Coming to the next part, this is the scheme, overall scheme, wherein I have taken the bromo derivative of coumarins and have converted them to azides by using sodium azide. And this is one part of my molecule. Then I have taken piperazine derivatives, which is reacted with propaxyl bromide and in the presence of potassium carbonate. and acetone and 80 degrees centigrade, and the reaction was carried out for 12 hours. And we have got a terminal alkyne, which is an important part for the which is an important moiety for the click chemistry approach. And using these two moieties, that is the azide as well as the terminal alkyne, I have got the final product. So with this final product, I have created, I have synthesized 10 derivatives. The derivatives are as follows, and the codes are 8A, B, C, D, E, F, G, H, I, and J. So these are the 10 derivatives which have been prepared. And along with the study, we have come across that AD compound was an excellent, showing excellent therapeutic potentials. And these are the references for the scheme which we have designed. Then I am showing, I would like to exhibit I have taken the NMR of all the compounds, but 8D being a potent, exhibiting excellent biological activity profile, I have chosen 8D as the compound. So that is proton NMR of 8D compound, and this is the C13 NMR spectra of 8D compound. Then following, I have also done the mass of AD compound as well as the FTIR of AD compound. So this was the spectral characterization of one of the derivatives which we have synthesized. Next, in this study, we have carried out 4 biological activity. That is, one is anti-TB, second one is anti-cancer, third one is anti-inflammatory, and fourth one is antioxidant activity. So the first one is in vitro anti-TB activity. Here the anti-TB activity was against MTB, that is Mycobacterium tuberculosis H37RV strain with isoniazide and pyranezumide serving as a reference standard. So this is the tabular column which gives the result for the anti-TB activity, and the MIC value is as follows. So here 4 compounds of mine have been showing good anti-TB activity in comparison with isoniazide. And out of them, AD showing the lowest MIC value, that is 1.4 micromolar, is exhibited highest anti-TB activity. So next, I have the in vitro anti-cancer activity by percentage inhibition of acetyl-CoA synthetase activity. This particular biological activity was a collaborative work. This is the second table, wherein the cancer cell lines which was used was HeLa and MCF7 cell lines. And there it was a very a good result which we obtained for again compound 8D, showing the IC50 values of around 12.42 for HeLa cell lines and 26.16 for MCF MCF-7 cell lines. This was in comparison with the standard cisplatin, and these are the references which I have jotted down. Next, and in vitro anti-inflammatory activity. Here, Coumarin piperazine analogues were tested for their in vitro anti-inflammatory action. Percentage inhibition of the Coumarin piperazine analogues were determined. Again, this activity, we have found it in IC50 value, that is micromolar concentration. And these are the final compounds. The compounds again 8C, 8D, 8E, and 8I showed good anti-inflammatory activity. And along with that, I'm also exhibiting the graphical representation for this anti-inflammatory activities. So this graph is against IC50 value against that of versus that of the tested compounds. Next, we have antioxidant assay by DPPH method. DPPH meaning diphenyl 1-picryl hydrazine method. So this is usually used as a scavenging method, antioxidant scavenging method, wherein again this is the tabular column which gives us the information regarding the synthesized compounds and their IC50 value values.
I just interrupted you. There is a screen. You should hide it. Okay. There is.
Sorry, sir.
There is a. Is there any screen on the screen? There is a hide option.
No, sir.
Because your text was marks. Okay. Is there any hide option?
There is only a stop
No.
sharing, sir.
Now it is clear.
Okay, okay. Okay, sir.
Okay, proceed.
Yeah. So this is the graphical presentation of the antioxidant activities. This was the 4 biological activities for the synthesized compounds which I have done. And we have also carried out molecular modeling studies. This was a doc view of compound 8F at the site of the enzyme PDB for DQU, and these are the conclusions of my study. So I conclude that 8D emerged as a significant candidate with MIC of 1.04 micromolar against anti-TB, surpassing the potency of the standard drug isoniazide. And we also concluded that 8D showed excellent anti-cancer activity compared to the other substituents against HeLa and MCF7 cell lines. And next we have anti-inflammatory activities, which showed wherein the several compounds demonstrated IC50 values in the range of 62.18 to 66.43 micromolar. And then moreover, compounds 8C, 8D, 8I, and 8J, this was for antioxidant properties. And finally, docking studies, as we have shown, demonstrated excellent binding energy along with favorable hydrogen bonding and hydrophobic interactions at the active site. And overall, the remarkable multi-target activity and promising pharmacokinetic profiles of compound 8D suggests its potential as versatile therapeutic agent, warranting further development and investigation in the quest for new treatments against tuberculosis, cancer, inflammation, and oxidative stress. So finally, I would like to thank ICCPMR for giving me this opportunity to present my presentation. Thank you, Madam and Sir, for your kind